Hello, and welcome to Maski Miller Learning and Maski TV. We are here again to try and make sure that we go this journey with you as you are inside Term 3. While you are busy preparing for your examinations and the test, today we are coming with another topic, grade 8, which is geometry of 2D shapes, but we have decided to only focus on the types of triangles and how do we deal with the triangles since we are recognizing the shapes. Okay, so the first thing that you need to know at the end of this session is how to then define different types of triangles, which one is called equilateral triangle, and then we have isosceles triangle, a right-angled triangle, as well as an ordinary triangle, which we call a scalene triangle. You need to be able to distinguish the different types of triangle, looking at their sides as well as looking at the angles. If you say something in a real life situation, you should be able to say this triangle is actually called the scalene, or this is a triangle that can be called a right-angled triangle, and so on and so forth. Okay, so as we are within it, as we said, we need to know how to define first before we deal with it. So here the type of a triangle, but before that, triangle is just literally a polygon with 3 sides that have 3 angles. So any shape that is drawn with 3 sides and 3 angles in it, so this is one of what we are talking about. If I had that shape drawn like that, that is called a triangle just as it is. So as long as it has 3 lines that are connecting one another, we then call that triangles. But it has also angles inside that will be given either by a same line or different line, provided that the angles are equal or they are not equal to one another. In most contexts, when you have a shape, you also have to know if their sides are equal or they are not equal. So please try to refresh and know what it is. So when I put one line, I simply say that the sides are all equal. And when I put 2 lines, 1, 2, and 3, I'm trying to say I'm not sure if these sides are equal or not. So I am going to represent them with these 3 lines just like that. So please make sure that you understand that as we go through the types of triangles. So the first triangle, as I indicated, it is the one we call scalene triangle. It does not have any equal sides and it doesn't have any equal angle. So when we label that, we could have just went and put 1 line and then we put 2 lines. And then we put 3 lines. Same to the angles. This angle you can see is very, very small, less than 90 degrees. And this one is also less than 90 degrees, but is small, then yet bigger than the first one. And then this last one is actually the bigger angle, but you can see that this looks like it's more than 90 degrees. So every time you see a triangle that has different sides and also different angles, size, you just know that is the triangle we call scalene triangle. Right. Then we have another one we call an isosceles triangle. An isosceles triangle, in most cases, it is defined by a triangle that has 2 equal sides and does not have the other side equals to them. So usually we call that side a baseline, provided that the isosceles triangle is sitting in this format that this one, the green one there, is sitting like. So it does have 2 equal angles and also 2 equal sides. Please just bear in mind that the angles that are equal must be opposite the sides that are equal. So it's not just any angle that will be equal. It has to be the opposite angles of those equal sides. That is what we call them equal. Okay. Then we have an equilateral triangle. This equilateral triangle just say everything in it is equal. So we have 3 sides that are equal. You can see that all the sides are actually just have 1 line, which means that all these sides are equal, and the angles, therefore, they all equals to 60 degrees. By the way, the sum of the angles inside each and every triangle are always equals to 180 degrees. You see we have actually highlighted it there to ensure that you understand. So if you have a triangle, one thing you must know about angles is that if you add them together, they must give you a sum of 180 degrees. All right, then we do have a different or additional to what we have there, another triangle that is also this, if you check here, this is also another scalene triangle, but it is in a form of us showing you that the angles and the sides are therefore not equal. And all the angles are less than what? 90 degrees. We usually call it an acute angled triangle because all the angles are smaller than 90 degrees. In other words, acute angle is an angle that is less than 90 degrees. So by definition, that's what we mean. But it's still the same as the top one is a scalene. Then we have a right-angled triangle. What makes a right-angled triangle different from the rest is that it has a 90 degrees on it. So that is very important because it has a 90 degrees angle which is represented by a square just as it shows on the purple graph, right? So that is always like that. The size can be equal or cannot be equal, either way, but then the important thing for this one, what makes you identify the right-angled triangle, it is the 90 degrees. Okay. Then we have an obtuse angled triangle, but that one as well, it's still a scalene triangle. It's just that it has one angle that is then bigger than 90 degrees, but less than 180 degrees. So that's why we're calling it an obtuse. But if they ask you the type of that triangle, we can literally call it a scalene triangle as well. All right. Okay, so here I just went and show you the different types of these triangles we're talking about and a little bit of a real life situation where we have. So you can see then we have said that all sides are equal. It is indicated in this diagram here. And also you can see that if we have this sign that is literally showing that this place is a no-go area or this place is a construction is happening and something like that. So you can see that it is actually an equilateral triangle shape, as you can see there. An activity that you can do at your side is you can just use a ruler with me and then we draw this particular one. But with you, you would have to measure it because you need to know how many sides does it have. So like if I start here and I go 1, 2, 3 like that, then that means I need to also do the same thing to this one. It has to be 1, 2, 3. If I do it like that and then I go this way and I say 1, 2, 3. So that is actually my equilateral triangle. Why? Because my sides are equal and that literally would make all that what you need. But with you, you're going to then measure this and make sure that all the sides are equal for the equilateral triangle to be true, which also make the angles to be equal as well. Then yet another one we have is an isosceles triangle. An isosceles triangle, as we said, it has two sides that are equal and the opposite angles of those sides, which normally they will be called base angles, are also equal. This an example we can find most of the top of the roof that we have if you have a roof just like this, or even a hut. If you remember that a hut one that we have, it also have that one. So all those houses that has this kind of a shape, normally they use an isosceles triangle with two lines equal, but the other one either bigger or smaller than the other, right? Try this, look around you and check whatever triangle you have and see if you are able to identify this particular one, right? Then we have another one, which is a right-angled triangle. I literally always just use the book for the right-angled triangle, because if you check the corner of my book, this book that I'm having here is platinum, there at the corner you can see there's a 90 degrees there. That is a right-angled triangle, just like that. There are rulers that also shows the right-angled triangle, and then you can find it if it's sitting like this. That is my right-angled triangle, just like that. right? And there's many things that you can use to check a right-angled triangle that is there, depending on the shape that you are looking at. Wherever you are, if you look at the triangle, or even if it's not a triangle, it's a door, but if you cut it like that, at the top, you're going to find your right-angled triangle, as well as the bottom, you're going to find your right-angled triangle like that, okay? Now, this is just a comparison just for us to recap what we have seen and what we know and what we don't. Please feel free to relate to anything that you know. Pop it in the chat if you need to, so that we can be able to move to the question. So look here, we have a type of triangles we have said, indicated that we have quadrilaterals. We have quadrilaterals. What makes a quadrilateral different from the others is that all three sides are equal, and all three angles are equals and also equals to 60 degrees. That an example was a road sign that we have seen. Okay, then we have an isosceles triangle that has only two sides that are equal, but also it has the two equal base angle in this case, which I said that the angles that are opposite those equal sides are the ones that are going to be equal. And then we have used a clothing hanger there to say, just to correct this first one, we did say that is equilateral triangle. So that's equilateral triangle. Then we have our isosceles triangle. Then we have our right-angled triangle. So right-angled triangle, if any sides can be equal or cannot be equal, so they can have all the sides equal, they can have two sides equal, or they can have none of the sides equal. But what makes a right-angled triangle differ from the rest is because it has one angle that must be equal to 90 degrees. So that is what we need to know. And here at the bottom, you can see that we have given you an example of how it looks and how we can get into the sum of the angles being 180 degrees. So we have our 90 degrees there. This one is an automatic say to say this is a right-angled triangle. And if we add it with our x as well as the y, that must give us 180 degrees. Those are the sum of the angles inside a triangle. Same as the isosceles triangle, which has two sides equal but the other not. So you can see that we have shown that these two angles are equal, but the third one is not equal to it. But still, it's a triangle. When you get to the sum of the angles of a triangle, you do the same thing. You add all the angles, they must give you 180 degrees. And then we have a normal one, which we just say scalene, an ordinary one, which does not have equal angles as well as equal sides. So both angles and the sides are not equal, but we use the same method to get our 180 degrees. And then we have equilateral triangle. In the equilateral triangle, we did indicate that all the sides are equal and all the angles are equal. Okay, so that is the summary that we have in this case, and I'm very sure that when you are still trying to process all these things and put it in your brain and make sure that you understand, we will together embark in a particular space where we have to try and answer the question. So I will give you few minutes for you to start answering this question as you relate. I will see you after the break. Stay tuned. Okay, we are back now. So let's go into this and try to see if we have managed to capture the summary of what we have to do as we are responding to the questions that is given to us. So please note and go back to this so that we can understand everything that it is on this first line. As I said, these are the types of triangles that we have. We said we have equilateral triangle, and we also have isosceles triangle, scalene triangle, as well as right-angled triangle. So let's recap. Right, with the right-angled triangle, we said that the very important thing of what you need to take care of or to note is that there is one angle that must be 90 degrees. If you do not have the 90 degrees, that cannot be right-angled triangle. Okay. Then also when we talk about isosceles triangle, we say that in isosceles triangle, what we need is just that the two angles must be equal, as well as the two sides that are opposite those angles must be equal for us to say it's an isosceles triangle. Whereas the scalene triangle have nothing equal. Everything don't really have to be equal. The angles and the side must be different for us to say this is a scalene triangle. Right. Then we have equilateral triangle, which an equilateral triangle, come rain or storm, it have to have the angles that are always equal to 60 degrees. Why? Because an equilateral triangle have equal sides. Another thing is that some of the angles inside the triangle, they always add to 180 degrees. And if you take 180 degrees, you divide it by 3, which is the 3 angles on the triangle, you're always going to get a 60 degrees. So that's why an equilateral triangle will always be equal to 60 degrees. And that is the reason, therefore, that an equilateral triangle will never be a right-angled triangle, because of the fact that one of the angles in a right-angled triangle must be 90 degrees, whereas we are saying that all the angles in an equilateral triangle must be 60. So that is what you need to look at and check. Okay. So let's go. Now let's do the activities together, right? This is taken from one of our textbooks today. Just the book that it's taken from, it looks like this. So if you go to the bookshop or you are shopping it online, this is the cover that you look for. In this book, there's quite a lot of information that you can learn about this. Yes, in addition to other books that we have, but it's explained it very well. You can actually be able to recognize and work with the shape as much as you can. And there is many activities and examples that can help you to do. So this was taken from page 143 of our today textbook, right? So let's go to it. Name the triangle with the following properties. So the properties is literally what we have just looked at in all this time. So the first one says to us, they are looking for a triangle that will have, let's fix that, a triangle that will have all 3 sides equal in length. So when that happens is you're just going to draw a triangle that will help you understand. Remember, I am not using a ruler, and you would have to use a ruler to measure and then be able to say which triangle, according to the properties, that has all 3 sides equal in length. We only have one triangle that has that, and that triangle we just have said it is a triangle that we call equilateral triangle, right? So that is equilateral triangle. Okay, let's write triangle. So equilateral triangle will be the triangle that all the sides that we have will always be equal, right? So that is 1.1. Then in 1.2, they are saying all angles are acute angle. So those angles that are acute angle, all of them are going to be what? So which one have all angles that are acute angle? So they did not say anything that is beyond, over and beyond. They just say that all angles are acute angle. I showed you one particular triangle that was talking about acute and obtuse kind of a triangle. So yes, when all angles are acute triangle, remember the definition of acute triangle just means that all the angles then will be less than 90 degrees. That means there's no angle that is 90 degrees. And when you come to that, you can literally use one, for example. This can be an equilateral triangle if we were told that all the angles are equal. But being safe for us, we can just call it an acute instead. An acute what? Triangle. So this is an acute triangle. But the acute triangle that we are talking about here, just to be safe, we are not saying equilateral triangle because we are not told that all the angles are equal. So if they said that all angles are equal, then we will be able to say this is then an equilateral triangle because all angles in an equilateral triangle always be equal. So please try to look at what they give us and we respond to that accordingly, right? The third one, they say only two sides are equal in length. Only two sides are equal in length. We only have one that has only two sides that are equal. And we have been talking about that one is an isosceles triangle. So that is an isosceles triangle that has only two sides that are equal in length. So that's what you're going to write. Then they said all sides have different length. All sides have different length. That will be our scalene triangle. So that is scalene triangle, right? So in that way, we would have responded to all our first up until the fourth question for number one, and that is what you do and how you respond to the question. Then number two, they went and said to us, okay, write the name of each triangle and next to that triangle, write the kind of a triangle according to the sides of the triangle and the angles of this triangle. In most cases, you just have to look at what is there and then you make a decision right from that. Okay, so first you're going to just check what is on A. So you can just say what kind of a triangle A is and what kind of a triangle B is and so on, right? So this is what we're going to do. So let's do that. Angle A is going to be angle A, or triangle A is going to be our right angled triangle. So let's see, right angled triangle. And that reminds me of something. The moment you say right angled triangle, that comes back to our acute. Remember, we say acute because acute is an angle. So that would be acute angled triangle, which we are saying that. So it's acute angled triangle because we are saying that the angles are also, all of them are acute angle, as we did for the right angled triangle. So if it was obtuse, we'll say obtuse the angled triangle. So that's how we name them with the angle that is given to us. All right. Okay, number B. So if you look at B, even if you measure it, you'll be able to see that the two lines here, they are equal, but this a bottom one, which we say base one, it's not really equal, and that will make it what? It will literally make it an isosceles triangle because two sides are equal. So that is an isosceles triangle. Right. Then C. If you look at C, you can see that all sides are literally not going to be equal here because this one is very small and this one is bigger, but it's bigger than the small one, but also smaller than this last one. You can see that this one is the longest side, so that makes it not equal. All the sides are different. All the sides are not equal, which is similarly to the angles there. Then we can call that one what? Scalene triangle. So all the sides not equal and all angles not equal, we call that one scalene triangle. Then number D, if you check it properly, even if when you measure it nicely there, you can be able to see that all sides are equal, which will make us have a different type of a triangle, which is equilateral triangles. Equilateral triangle. So that is how we have identified, we have found all the types of triangles that we have been dealing with, and we were able to record them or write them according to their triangles and the names, the shapes, and the sides that we have. So this is the kind of things that you have to do as you are practicing all the time, and make sure that you understand the types of triangles that we work with so that you can be able to deal with them anytime. Now we went to one of our other book that you might have with you, and if you do, please just open page 105, and then in page 105 you'll be able to find this kind of questions. There's many of the questions there which can help you to understand this. So I am right here in page 105 where there's quite a lot of questions that we can go with it, and you can be able to get all what you need to be able to identify and classify the types of triangle that we have, as well as finding the angles that you don't have. So from this book, if you have it, open it, and if you don't, you can shop it online and you have it on the phone or anywhere for us to be able to work together. Right now, let's do this together. So in there, they've given us a question. They say consider each statement carefully, and if it is true, write just T, and then also you draw that triangle that you are talking about, right? So if it's false, just write F and give a reason, excuse me, and give a reason of why you are saying that it is not, right? Then the first one they say, is it possible to have a right-angled scalene triangle? Is it possible to have a right-angled scalene triangle? So what it is that you're going to do, just go back a little bit of what we had. That is an example, right? We have this right-angled triangle on this one and in many others. You can see that this is a very small size, and this one is big, but it's not bigger than that. So you'll be measuring this thing and you are able to see that then there's a difference between these three lines. So that means if they are not the same, they are. The triangle is a scalene. So that means it is possible. So what you're going to do there is going to write the T, and then you draw your right-angled scalene triangle. So let's do that. Try to draw it like that. And always remember, if they say right-angled, your 90 must be shown. You can't have a right-angled triangle which is not showing the 90. So every time we say there's a right-angled triangle, you always have to show the 90 degrees there, right? So that is the right-angled triangle there. That is a scalene. So you said yes, and then you show how it will look, right? Is it possible to have a right-angled isosceles triangle? So that symbol means that you need to have two sides that are equal. Is it possible? So you can measure and see if that is possible, or we can just quickly do a draw. Let's do that. So if I have a straight line going 2, and then I have another one going 2, since I don't have a ruler, I'm just using the lines here. So in my way of doing this, I am trying to say that yes, it is possible, because I've drawn this to have 2 units and that to have 2 units, whereas I have this one not having 2 units, but this is my right angled as well. So it is possible. Then I'm going to respond with a T as the instruction has come to me. So this is literally what they want us to do and how you need to respond to that, right? Is it possible to have a right-angled equilateral triangle? What did I say during the consolidation? I did say that it's not possible that we can have a right-angled triangle which is an equilateral triangle. Why? Because an equilateral triangle have equal angles where each and every one of them equals 60 degrees. So that is no, it's not possible. So you're going to come and say no, which is a fault, and then you indicate that equilateral angles equals to 60. Or you can say each angle in an equilateral triangle is 60 degrees. Or you can say it cannot be 90 degrees. So you can say that none of the angles inside the equilateral angles will be equal to 90 degrees, right? Just like that, you can do that, and you can respond to that question as well, just like that. So that was number C, number D, number E, and number F. That is the one that I want to give it to you for a homework for you to then go and try and respond to the questions as you are able to write them down. So you're going to check if it is possible to have an acute angle that is an isosceles triangle, as well as an obtuse angle that is an isosceles triangle, and then you're going to then use another information that they said. Is it possible to have a triangle that has a 5 and a 6 and a 7 as their sides? Try that. Please go draw them so that you can be able to talk to them as you chat with us in any other space that we have, or you can actually talk to us in any other platform that we have, including Musky. So you can then go ask Musky to say, is it possible? Musky will give you the answer. The number for Musky is 072-091-0388. Please talk to Musky. Musky is there to assist you at any point and time that you want on your WhatsApp at your fingertips using your phone. And the next lesson is going to be similar and congruent triangles, which will be under 2D shapes as well. But please feel free to tell us what it is that you would like us to teach you or to assist you with, since we are intervening to assist your teachers. I hope you guys have understood and you have enjoyed the lesson. If not, catch up. Make sure that you share this with your friends as well as subscribe. We will see you next week. Bye.
And now we enter our next exciting chapter with the launch of Maskyverse, an inspiring trio of innovations, our AI-powered learning companion, captivating TV content, and a vibrant playground for interactive learning, and our own dedicated app, all coming together beautifully to deliver learning outcomes through technology.